Okay, our last problem is going to actually be writing a piecewise function f of x. So basically what I'm looking for is something where f of x equals, it consists of three sections, this part in purple, this part in red, and this remaining part in blue. Okay, so we have three sections, so I'm going to make enough basically for 1, 2, 3 parts. Okay, and modeling my earlier one, you could say when or if, and I want to go x is in between, let's see, 1, 2, 3, 4, 5, 6, 7, 8, negative 8 to negative 5 when x is greater than negative 8 but less than or equal to negative 5, and I'm just choosing this to be closed in purple. Okay? I could have chosen it with the red section as well. The main thing is one of those is going to be open, one of them is going to be closed. The red section starts at negative 5 and it works its way up to, let's see, 1, 2, 3, 4, 5, 6 it looks like. So I'm going to say less than or equal to 6. Now notice, since these connect right here and right here, one of those points has to be closed, so we have to have the equal sign like I chose right there. The other one needs to be open without the equal sign. We can't have it defined at both of those values. Ultimately it's going to end up the same either way. So finally the last part is when x is in between 6, and since I made 6 equal to on the last one, I have to make sure that it's open on the next one. And then I'm going up to, looks like 7, 8, 9, 10, 11. So less than or equal to 11. Okay, I have closed circles there, so we have that equal sign. All right, these two can't be both equal unless they were, since they're both defined at 6. Okay, next thing we're going to do is simply write the equation of this line. We're going to write the equation of this line, and we're going to write the equation of this line. I personally like that red one the best. If I count up 1, 2, 3, 4, 5, 6, 7, this is the equation y equals 7, or f of x equals 7 when negative 5 is less than x is less than or equal to 6. This in purple we have a positive slope, in blue we have a negative slope. We could count it out if we wanted. Okay, I know the rise is 1, 2, 3, 4, 5, 6 it looks like. Okay, goes from 1 to 7, so that makes sense. So for in the purple, my slope is positive 7 over a run of 1, 2, 3. Okay, so getting some practice with point slope form. What I'm going to do is I'm going to pick a couple points. I'm going to choose this guy right here, and I'm going to say that's up 7. And we have 1, 2, 3, 4, 5. Looks like negative 5, 7. So if I said y minus y equals m times x minus x, pardon the bell, I'm going to put it in function form since it's f of x. So I'm going to distribute, I'm going to add 7, so I'd have y equals 7/3 x plus, think of that as over 1, that'd be 35 thirds plus the 7 from the other side. 7 to get a common denominator of 3, so I would take 7 over 1, take top and bottom by 3, and that'd be 21 thirds. Okay, so I would end up with 7/3 x plus 54 excuse me, thirds. Doesn't reduce, so I have f of x equals 7 thirds x plus 56 thirds when x is in between -8 and -5. For the last section, we have this section in blue. Okay, we went out 11, so that'd be 11, 0. We went up 7 when x was 6. So in blue, my slope would be rise over run would be negative. The rise would be 7, the run would be 5. So right now I have y equals -7 this x plus some b. I know my b is way up off the axis, so we're not going to have a nice value to be able to just plot easily. So since I did point slope on the last one, I'm going to do slope intercept on the next one and show you a little different approach. So I had -7 fifths x plus b. Since I don't know the y-intercept, I know the x-intercept. I'm going to fill in 11, 0. So I had 0 equals -7 fifths times 11 plus b. That's 11 over 1. So that'd be -77 fifths. If I add that to the other side, that would be positive 77 fifths for b. So I have plus 77 fifths. Now, those are not pretty. I didn't intend for them to be. Gets us some practice working with equations of lines, but specifically applying those to piecewise functions. And ultimately, ladies and gentlemen, that is the piecewise function f of x that satisfies that graph.